my name is Dr. English and welcome to Atomic Structure 1, Atomic Mass and Isotopes. Today in this tutorial specifically we're going to look at understanding atomic mass, calculating atomic mass, understanding what is an isotope, and a little bit of practice at the end. So understanding atomic mass. What is atomic mass? So if you've watched previous tutorials, as you've learned in your chemistry classroom, atomic mass is going to refer to the number of protons and neutrons inside of the nucleus of an atom. So those are the two subatomic particles found inside the nucleus. And also these particles represent most of the mass of the atom, not all of it. Some of the mass is attributed to electrons, but it's a very, very tiny amount. Most of the mass is found in the nucleus. Also remember, the mass of a proton and a neutron are relatively equal, around 1 atomic mass unit, which we represent as a U, but don't be surprised if you see this also represented as a MU. That also can be used to represent atomic mass unit. Calculating atomic mass. Well, atomic mass is composed of protons and neutrons because, as we said before, that's where the mass of the atom is located, inside of that nucleus, and those are the two subatomic particles that are located there. So when you calculate atomic mass, you're going to find the mass of the protons and add them to the mass of the neutrons. So let's look at an example. An element's nucleus contains 13 protons and 14 neutrons. What is the atomic mass? So I'm going to take my 13 protons, 13p, and my 14 neutrons, and all I'm going to do is just add these two numbers together. So I'm going to get 7 and 2. So the atomic mass would be 27U. Let's look at another example. Beryllium has an atomic mass of 9 and an atomic number of 4. How many neutrons does the nucleus contain? Well, remember, atomic mass, if we abbreviate this out, atomic mass is equal to protons plus neutrons. Protons plus neutrons. And in this example, we say that that is 9. Now, atomic number, as we've learned previously, is the same thing as number of protons. So in this case, the number of protons will be 4. So if I take my atomic mass, which is composed of protons and neutrons, and subtract the atomic number, which is the number of protons, subtract these two, I will get 5. Another method that students use is looking at their periodic table and their reference tables and saying to themselves, well, the atomic mass is located in the top and the atomic number is down here. So also if you just subtract those two, because they're conveniently lined up, 9 minus 4 will give me 5, and that matches what we originally have. So atomic mass, protons plus neutrons. Now what is an isotope? We define an isotope as atoms of the same element with varying numbers of neutrons. So isotopes are going to have the same atomic number but different atomic masses. So when we look at isotopes, we look for their mass number and the symbol. So isotopes are indicated by their mass number, which is either written after the name or to the upper left of the element symbol. So for example, we might use something like carbon 12, where the carbon obviously is the element and the 12 is the mass number right here. Mass number. Another way of representing it is the symbol of carbon for C, and then the 12 superscripted, or even another method could be the symbol C and then a dash 12 after it. So all three of these representations represent carbon 12. Let's look at an example. Which of the two following 3 atoms are isotopes of each other? The way that we can figure this out is by looking at the number of protons and neutrons in each element listed. So for carbon 12, the number of protons is equal to 6. Carbon 14, the number of protons is also equal to 6. And in nitrogen 14, the number of protons is equal to 7. Now let's look at the number of neutrons for each one of these. So neutrons. So for carbon 12, 12 minus 6 will give me 6 because, or going backwards, 6 plus 6 will give me 12. For carbon 14, number of neutrons, 14 minus 6 gives me 8, or 8 plus 6 gives me 14 as a check. And then finally, for nitrogen 14, 14 is my atomic mass. I have 7 protons, therefore my number of neutrons must also be 7. Now, specifically, to figure out which ones are isotope, I need the same atomic number or number of protons, but different number of neutrons. So if I look at the information that I have here on the bottom, for carbon 12 and carbon 14, they have the same number of protons. Same number of protons here. But the number of neutrons is definitely different. Carbon 12 has 6 neutrons, while carbon 14 has 8. Nitrogen 14 is not an isotope of these, for the primary reason that it doesn't have the same number of protons, therefore it's not the same element. That by itself pretty much disqualifies it from being an isotope of carbon. So carbon 12 and carbon 14 are isotopes of each other. They have the same number of protons but different number of neutrons. Let's do some more practice. Consider 3 isotopes of oxygen. Oxygen 16, oxygen 17, and oxygen 18. And I know they're isotopes of each other because they have the same symbol for each of them. Each of them is representing oxygen. So in terms of subatomic particles, what do these isotopes have in common? You have to be careful here. You can't say, oh, they have the same symbol, because the question specifically asks in terms of subatomic particle. And if your answer was protons, you're correct, because if I look at oxygen, each one of these oxygen isotopes is going to have 8 protons because the atomic number is 8. In terms of subatomic particles, what is the difference between the isotopes? Well, 16, 17, and 18, they all have different atomic masses, but we know for each one here, they have 8 protons. So what could the difference be? If you said neutrons, you're correct, because if we went through here and figured out the number of neutrons, they would all be different. The number of neutrons for oxygen 16, if we can shove it in here, would be 8. The number of neutrons for oxygen 17 would be 9. And the number of neutrons for oxygen 18 would be 10. Let's look at this final example at the bottom. A neutral atom with 6 electrons and 8 neutrons is an isotope of what element? Alright, so a neutral atom. Well, atom tells me that protons has to equal electrons. Protons has to equal electrons. So if I have 6 electrons, that means I have 6 protons. And if I have 6 protons, that's equal to my atomic number. So what element here has 6 protons? If you answered carbon, you're correct. What about the neutrons? Well, the neutrons here, it's an isotope if this was like carbon 12, but more it's a distractor than anything else. They're trying to distract you away from what's the real focus, and that is looking at the word atom. Don't be misled. Now it's your turn to do some practice. So stop, do the 2 practice problems here, and then when you're done, come back and check your work with me. Welcome back. Let's go over these 2 examples. Which symbols represent atoms that are isotopes? Okay, so like we said before, with isotopes, the number of protons has to be the same. The number of neutrons has to be different. And I'll make a little note up here. The number of protons has to be the same. Okay, so which one basically has the same atomic number? I look through here and I say, all right, well, this is oxygen and that's oxygen, so that's a possibility. Carbon and nitrogen, not the same number of protons, so goodbye A, you're not a possibility. We go to B. Rn and Ra, really close, could be misleading, but not the same element. Plus, the atomic masses are the same, but the elements are the same. So because the element symbols are not the same, not a possibility. And then we get to D. I's are the same, so that's a potential possibility. Now, the neutrons have to be different. So that basically translates into the atomic masses have to be different. So I look at oxygen 16 and oxygen 17. They have different neutrons. Oxygen 16, as we've seen before, let's see, protons here 8, and then neutrons would be 8. But oxygen 18, protons would be 8, but neutrons would be 10. Over here, iodine 131 and iodine 131. Well, those are the exact same elements with the exact same masses, so no, not the right option. So that leaves us with C as the correct answer. So if you got C as the correct answer, good job. Let's look at this example right here. What is the mass number, atomic mass, of an atom which contains 28 protons, 28 electrons, and 34 neutrons? So we have 3 subatomic particles given to us. The key thing to remember here is that the mass is composed of protons and neutrons. So to figure this out, we do 28 plus 34. So 28 protons, 34 neutrons, and we'd add those together. We get 12 and 62. So 62U for my mass. 28 protons, 34 neutrons. Yep, my math works out. And do any of these answers work out to be that? Oh yes, they do. And it's C again. Obviously, I'm really original. If you got both of those answers right, good for you. So what did you learn in this tutorial? Well, we went over what is atomic mass. We learned how to calculate atomic mass. We went over the definition of an isotope. And then we had some practice at the end. Need more help? Please feel free to contact me. Have a great day.